multi-tenancy. And you are probably wondering, what do they all have in common? And I hope you will figure it out today as well. Before that, let's thank our sponsors, because without them, we wouldn't be here today. So that is extremely important. So I'm Florin. I am a career manager and the head of DevOps engineering services at Yonder. Generally, from a technical point of view, I am specialized in cloud computing and especially deployment automation, which is a big passion of mine on pretty big networks and infrastructures. And I'm also extremely passionate and avid about information security. So before actually going into the discussion that I prepared for today, I will show you a bit what I understand from this concept of continuous delivery, A/B testing, and multi-tenancy. So according to Wikipedia, this is the definition of continuous delivery. And that's no news for anyone, but what I think that it is one of the most important words from this definition is that the software can be reliably released at any time. Of course, most of the continuous delivery process is actually about processes and the way you develop the software, the way you manage your source versioning system and all kind of things like this, but I'm not going to talk about that today. But I will try to show you how you can achieve a safe level of delivering the software in a continuous delivery way into production. So it is very important that we have, first of all, before getting into the technical solution, the ability to deliver that software. So that means automated build systems, automated deployment systems, and everything already in place. So A/B testing. When it was first used in software development, actually it was used mostly for user experience testing. So, for example, the guys at Google tried it, I think, one of the first times in 1990-something, when they said that when they put a new feature into production, they want to see what is the reaction of various users on various versions of the same implementation. So, if I have a form and a button, the submit button, for example, is on the left or on the right, is that relevant for my users, and does it improve the click rate or the conversion rate of the form or whatever that form means? So what they did was to pick a small portion of their user base, like 5%, 10%, or even smaller, depending on the application and whatever the user base was, and they split that those users in half. For half of them, they put the button on the left, and for the other on the right. And they said that, okay, now we are going to monitor the user experience and see whichever was used better by our customers and which was had the highest impact on what we expected. However, today, I will consider as A/B testing from a more technical perspective. And that is to be able to do production testing with your customers together. Because software development, when you are doing agile software development, is also about delivering the software together with your customers all the time. So I think that the testing the production environment is extremely important. Also, I will refer to it as a way to control the continuous delivery impact. And for that, of course, you do quality control, and so which is QC, and I have another word which is DC, which means, in my terms, damage control. So when you deliver a new version, which is maybe a big release with a lot of new features that radically change the application, of course, business people usually are very hesitant about it. So they require a lot of testing before, but you can test the software in a testing environment just as much. So you want to control how many of your users are impacted by the new change and how are they impacted. And if there are negative consequences, it's not all your user base that is actually impacted. And it will also imply rollout flow control. So how are you actually putting new versions or new features live to your customers? And customer-defined rollout. So sometimes when you work for ISVs, you know that you have your product sold to multiple customers, but each of them has a different view and a different approach into new versions and how they should be delivered to them and how much risk are they going to take in order to release a new version. Multi-tenancy. Basically, it means that an instance of your application or a cluster of your application in the production environment is able to serve multiple tenants at once, so multiple customers at once. And to give you an example, for example, we have an application that is sold to pharmacies, and they use it to register the drugs that are being purchased or all kinds of things like this. And each pharmacy has their own database with their own patients, their own drugs that are selling and all kinds of things, which is the tenant data. And they also have configuration, like what doctors are allowed, for example, to send prescriptions to that pharmacy, or whatever else, what systems, upstream systems from government maybe, or other organizations are they contacting and sending the information and reporting and things like this, which is tenant-specific configuration. And the same code base, the same instance of the application should have the ability to deliver the software for each of these tenants. And in this context, data separation is extremely important. So this is what I say about multi-tenancy and what is my view of multi-tenancy. So where did everything started of what I am about to show today? It started with this product. It's called iBurgersachen. I hope I pronounced it correctly. Dutch is a very not easy to learn language. So it's owned by one of our customers called Pinkroca, the local government. They started to develop software in 1980 something. Of course, the mindset at those times was to deliver the software once a year on a floppy disk to every municipality. It will run under the desk of a civil servant on a laptop, and unfortunately for many, many years, because they had kind of a monopoly on the market, they didn't think about new ways to deliver software, new ways to build software and things like this. So they kept, maybe the software itself evolved because there were new requirements, new business, but the mindset of delivering it was still the same. So releases were still every few months, still delivered by a CD or maybe downloadable content to the municipality. And with this product, this customer tried to revolutionize the way municipalities work in the Netherlands. So it is a software for Dutch municipalities, like you would go to the city hall and try to register the birth of your child or things like this. So they came with this idea, it's called government as a service. So they said that we want to have the application exposed as software as a service, where both the citizens and the civil servants are able to connect to an online platform where they can handle all the citizen relationship stuff and things like this. So they started writing the application. but of course the mindset did not change. They had BPM software at the center of the application design, which had no multi-tenant capabilities. And they started to write the software. And halfway through, they started thinking about how are we going to deploy it? How will it look in a production environment? This was about after, I guess, 2 years of development or something like this. So we ended up with a list of requirements like, okay, it is a web application, but it needs to be multi-tenant, it has to have full automation on deployment of new releases and new customers and all kind of things like this. And when we started working on that, we realized that, okay, but this application has no support for multi-tenancy. There is no discriminator for every tenant in the database, and all the database was very abstract because it was generated by the BPM software. So it was kind of painful to watch how it wasn't really very easy to do it. To implement it inside the application, it would mean to go through 2 years of code and partially rewrite it. So we thought about multi-tenancy outside the application to provide it as a layer in the container that runs the application. So what we needed in order to do that? We needed tenant discovery. That was really easy to do. We had a servlet filter that would basically read through the request that was coming, check the HTTP host of the request, read the first part until the first dot, and we said, okay, that is the tenant. And every tenant would have their own URL that they would access the application through. So that was solved. Then there came the tricky bit. We said that we want to put the data for each tenant in a different database, in a different database cluster altogether, due to both legal requirements and constraints, and also to isolate and build them individually and all kind of things like this. So we needed this data source selection process to happen. And what does that mean? It means that when actually the BPM software is connecting to the database in order to get information, it will need to receive from an intermediary layer a connection from the specific database for that tenant. Of course, there are many ways to achieve this. In Java, you can, if you use Hibernate, for example, it has multi-tenancy kind of out of the box. You just need to have a context provider that provides the tenant context and a way to get the connections. So we defined each data source for each municipality as a separate data source. The data source name in JNDI was using the tenant name. It was easy to discover it. So yeah, it was a nice solution. And of course, you needed a tenant context where to store all the information and be able to deliver from the servlet filter all the information to the data source selection mechanism. And that was very easy because the application did not use asynchronous requests, so we put everything on thread local variable and everything was easy peasy. But business is business, and new requirements came. And new challenges for operating the actual infrastructure. First of all, we started with 2 customers, so 2 municipalities, let's say 2 small towns that we were delivering the software for, like, I don't know, Huși and Vaslui or something. And it was okay, everything was running perfectly. But then we ended up with like 150 of them, some of them even bigger. And during a release, we had to run database migrations for each and every of them. And the release window started to grow and grow and grow. And the complexity of delivering the software actually became bigger, even if the software was multi-tenant. Also, the customers started to say, but okay, we want to deliver some bigger releases to each of the customers gradually. So we have a very new, shiny module, but we want it to go to some customers that we have a better relationship with, because they are more understanding to us, and if we have some major bugs or other big issues, then it will be easier to explain and manage the whole situation, comparing to putting 150 municipalities from the Netherlands, that's about half the country, to wait for us to fix problems and so on, and their civil servants are sitting at their desk, are not able to do anything. So it would freeze the whole municipalities around the countries. So the first idea was, of course, to just create a new cluster. We will install the new version on a new cluster, then we will redirect the traffic from a load balancer depending on the municipality to the new cluster. But when we started to actually put it on paper and think it through, the complexity of doing this was much bigger than it sounds. Because, okay, you need to do that, but you need to also upgrade the database schemas, so do all the migrations for the new release. That means that our database deployment process was no longer usable. We needed to rewrite it because it was doing them all the time. We needed to filter them depending on which cluster would they run on. And it was pretty painful to watch how we would have worked for a lot of time in order to provide something such simple. So I said that we should think a little bit outside the box and come up with a solution that still comes from the outside, so no actual implementation in the application. The application would remain just that it is a normal standard web application. So I said that now, instead of a one-to-n relationship between the instances and the clusters and the code that was running the actual production environment, we would have an end-to-end relationship. So configuration management is pretty much, I think, just the same as databases, because you still have configuration entities and you still need to map them, and of course you cannot map an end-to-end relationship. You need to put something in the middle, and I called it a multi-tenancy context. So what does this multi-tenancy context do? It has the previous schema that I showed, where you have the tenant discovery, the tenant context, and the data source selection process. And I said that we want something in the middle, multi-tenancy configuration, which can provide the application, actually not the application, but the module that we have that does all those things, a more dynamic configuration that is very easy to handle and to do. So we ended up actually putting it in a database. And we have a database storing all the tenants that we have. And we said that when a new application cluster, well, a multi-tenancy application cluster, let's say, because it could be different than an actual state storage cluster, when it starts, it will expose itself in that database as a new cluster, and you could start assigning tenants to it in that configuration. And of course, the filter will be implemented in such a way that the cluster would only serve tenants that it is supposed to, that are assigned to it, and everything went pretty fine. We added another process called tenant initialization. And what this means is that when I start a new cluster, it will boot up. It will add an entry with the new cluster in the database. And then I can simply go to the tenants table and assign each tenant to the new cluster. And when that happens, the old cluster decides automatically not to serve new requests for that tenant. The proxy or the load balancer in front of the application knows to route the new requests to the new cluster. And the new cluster initializes the tenant on its own version. That means that it takes care of the database migrations from inside the application before it starts to actually serve requests for that tenant. And everything seemed easy to implement, easy to be realistic that it can deliver what was requested from us. And after studying this a bit more, I realized that it is much more than a multi-tenancy module, a multi-tenancy configuration, because you can use it for various other purposes. So what I think that we delivered is business value, because that's what a CEO likes for any product, any company, which is money. And it doesn't matter the technologies, it doesn't matter the tools that you are using, unless they are very expensive, of course. What it matters, it's money. So what we ended up having by simply changing a little bit the structure that we had. Smoother releases. Now everything, you can prepare for a new release much more in advance. So you can actually create the new application cluster in the production environment way long before the actual release. Because the actual release simply means changing that tenant, that customer, to be served by the new cluster. That is the actual release. That's when the end users actually see the change. Nothing stops you from having test tenants that you can test in advance the application with. Then when you assign actual tenants, you can do them in batches or one by one or whatever you want. It takes seconds because all it takes is to actually run the database migrations, which you can be done in parallel and all kinds of things. So it is very fast. And you can achieve a very interesting thing from a business perspective, customer-driven rollouts, which actually a customer can decide. Of course, you have to take care that they don't use 10 versions ago, but the customer can decide when they want to switch to the new version. So if they have an important event, or if they are simply reluctant to untested software, they can decide that, okay, you are doing a new release. I want to see how it goes for other 10 customers, and then I will also upgrade. And of course, the maintenance windows are way smaller now, because comparing to deploying the new you have application servers. If you want to upgrade them, you have to put them down. After you put them down, you need to upgrade the databases, so run all database migration. And that takes a long time. Now everything is done beforehand, and it's much more convenient. And what is also very interesting is that you can actually sell this to a business guy. So if the CEO comes and says, okay, you want to do continuous delivery, that's very risky. I mean, if you put a bug in there and you deliver new software that does not have the required quality, my customers will complain. What would I want to do that? Because what I have now works. But you know very well that in order to deliver what he wants in terms of business requirements, you have to have continuous delivery most of the time. Now, they can feel much more in control. So I think that business value is the best word in what we can say about such a solution. So you not only deliver continuous delivery and some sort of A/B testing for you, which is a value for you as a developer or as an operations team or whatever, but you also deliver what is very important for the business that you are working with, for. Okay. So, questions? Yeah, well, multi-tenancy is not about necessarily running all your customers. on the same platform. I mean, your platform is multi-tenant if it supports running multiple of them. But of course, ideally, and what we do on other projects, in this one it wasn't required, but in other projects that handle multi-tenancy, we separated clusters for very big customers. They are paying much more anyway most of the time, so it's not really a loss. And you would want them to be separated. So because you always have customers that use like 90% maybe of your resources, and I think it's always a big value to just have them on their own separate clusters, or maybe just on clusters that handle way less customers at a time. And the rest of them, which you separate it. Yeah, but in a multi-tenant environment, if it runs all together with the other customers, it will impact all of them. Right? That's the whole point. Yeah, but you decide that. And that's a matter of... Sorry? Not in this case. So, I mean, it's hard to do it. What you can do, and what we did before, were estimations. Estimations of performance, impact, and system usage in general. So you need to think about the metrics of your business. And in this business, for example, the metrics that we considered are some data from the National Statistics Bureau from the Netherlands, which provide how many people move or change their house every year, how many people are born every year per 1,000 inhabitants. So we have the number of inhabitants that each municipality has. We divide it by the number of cases per 1,000 inhabitants, and we decide, okay, this municipality is going to have about this many cases of whatever they have to do, emit driver's licenses and so on, every year, and comparing to others that are using about the same, he is a bigger or smaller customer, or will use much more or less resources and so on. So very important is to, but this is, no, big data, analytics and stuff like that. Yeah, yeah, of course. In such an application, it is much easier to know your customers. I mean, it's not an infinite number, virtually. Yeah. Yeah, yeah, I understand what you say. It's hard to predict that. Well, my guess is that you would limit them in advance. That's what I would do, and I think other companies. So, for example, if you create an AVS account, you have certain limits on the resources you can create. No, so in this case, it's not a problem. Anything else? Yeah. What happens if you find out that once the customer is a client starts moving data, you see that the release is bad? How do you roll that? Yeah, depends on what happens. So either you patch it, of course, but if you have to roll back, we are using some scripts for database migrations that have rollback capabilities. And we roll back. Of course, we also have backups. So we can just restore the databases to the state of before the release and move them back to the cluster. I mean, moving them back and forward between the application clusters doesn't matter the version. should be possible no matter what way they are going if the database migrations have the capacity to roll back to a previous state. So if you add a column, you know that you can drop a column and things like this. If you delete data, it's more tricky. But generally, rollback should have exactly the same flow. I mean, you just change the cluster that they are assigned to, move it there, the migrations will run, it will know that it is an older version, and it has to execute rollback, and it just executes rollback, and it comes out of the box. In theory. In practice, of course, rollbacks are always sensitive, depending on what you do during the upgrade. As I said, that's the worst case that you can do, worst thing you can do during an upgrade migration, to delete data. So if you do delete data from a table, then you should have backups. But that's the idea. Did I answer your question? Anything else? That's the point of multi-tenancy, not to have servers for every customer. You have servers for every generally cluster, but it depends, because what we are going to do soon enough is to go to containerization, which is a bit different, because it's much easier to launch new clusters, upgrade them, whatever. Something else? Okay, thank you. Please offer your feedback on the session, and I hope you enjoyed it. Thank you.